evaluate this triple integral, and these are the limits for x, y, and z. So we have this integrand. Since we have x square plus y square plus z square, which is in fact x square plus y square plus z square is rho square in spherical coordinates. So we want to apply spherical coordinates in this case, that is change these limits into spherical coordinates limits. Okay, that's the case. So this part is done. And if we look at here, this g has lower bound this and upper bound. That means, let me work with lower bound. Okay, that's -1 negative square root of 1 minus x squared minus y squared is less than equal to g. Okay, let me put lower bound just g. Square both sides and move this over, so we get 1 equals x squared plus y squared plus z squared. That's 1. So basically a unit ball. Okay, a ball centered at 0, 0, 0 with radius 1. And if we do upper limit, we get to the same equation, unit ball again. Okay, looks like we have unit ball for z coordinate, and its projection, if we look at the xy plane here, in x it has bounds -1 to 1, -1 to 1, and y has bounds y. Let's look at lower limit. Lower bound is 1 minus x squared. So if we square both sides, we get y squared equals 1 minus x squared. Move over, so we get a circle from lower bound. If we do the upper bound, same thing. So basically we are integrating this function on a unit ball. Okay, unit ball, that means we know the limits for in terms of spherical coordinates. So we know that is theta, rho, theta, and phi. So this is then, that is same as, this translates into rho square sine phi d rho d theta and d phi. Okay, just the volume change in volume part. And here is the integrand e raised to rho square raised to 3/2, 2 to cancel rho cubed, so e raised to rho cubed. And about the limits now, rho, theta, and phi. So we have a unit ball, so 0 to 1. Okay, centered at 0 and outermost is 1. Theta, if we look at the xy plane, it's going, we have a unit circle, so 0 through all the way to pi, and this has the full limits, but phi is always 0 up to pi. Okay, and look at these limits, these are all number limits, 0 to 1, 0 to 2 pi, theta 0 to pi. That means we can just put these corresponding functions in correct place and do at once. Alignment phi from 0 to pi, we can bring this sine phi d phi, so sine phi d phi, and we can work on this because the limits are just number limits. And how about theta times theta from 0 to 2 pi, we don't have anything, just d theta means 1 d theta, that lifts about, now rho, that is rho from 0 to 1, we have e raised to rho cubed times rho squared d rho. Okay, let's evaluate this. Antiderivative of sine is negative cosine phi 0 to pi times antiderivative of 1 is theta from 0 to 2 pi. Here we got a product, So let's try to use the u substitution. U equals p rho cubed, and its derivative is 3 rho e squared d rho in terms of differentials. So we don't have 3's, but we can multiply by 3 and divide by 3. Okay, that makes this whole thing as e raised to u, and this one is like du. So we have eu du, which is just e raised to u. So in this case, 1/3 outside number, so eu, which is rho cube, and we go from 0 to 1. Okay, upper limit cosine pi, which is -1, negative of -1, 1 minus lower limit negative cosine 0, 1, -1. So that is here times 2 pi minus 0, just 2 pi, 1/3 e raised to 1 cubed 1 minus e raised to 0, 1. Okay, let them put together. So this is 2 pi, that's 2 times 2 pi, 4 pi over 3, and inside just e minus 1, final